Well, think about for just a second here. The process we said is endothermic or exothermic?
Supposed to be endothermic.
Endothermic, okay? So if it's endothermic, that means that it takes heat in. Where's it going to get the heat from? The water. So if it's getting heat from the water, Montian,
So it should go down.
it should go down, right?
Right.
My name's Tim Percoski, and I'm a science teacher. And the students in this lesson are in AP Chemistry. Today the students were working on an inquiry experiment in which they were confirming the idea that the entropy for the experiment actually drove that experiment happening on its own, the spontaneity of the experiment. And while it was content related for sure with respect to, we're learning the laws of thermodynamics and working towards the AP test for chemistry, it was really more of an inquiry lesson where the students were given a task of trying to develop their experiment. And in developing the experiment, trying to find ways to come up with data. Students really learn best in the inquiry model in my eyes, because what it does is it constantly challenges them to exercise what they know in order to solve something that is unknown to them. It allows them to tie what they're currently learning to previous information. It allows them to use the new information for future understandings. And it also has allowed for transfer for students between content areas, whether it's interdisciplinary between other sciences or to other content areas altogether. I just think the nature of asking and answering questions is a good way to learn. From the graph, because if we're able to plot various temperatures and we're able to get various values for delta G, we could create a slope of a line. The slope of that line would equal delta S, and that would prove to us the entropy drift. Well, the problem is the delta G that you have would have to vary with temperature. And what temperature are we dealing with in this room? I mean, is the temperature changing in this room?
On a different day, maybe.
But for today's purpose?
No.
No. So, in other words, I guess what I'm trying to say is that do we have the ability for this experiment to plot a graph?
No. Not so much.
We're limited a lot with respect to that, because we're not going to be able to vary temperature in the room by that much. In a true inquiry model, the questions are being asked throughout a lesson, and the answers to those questions are coming up as a result of the lesson going on. So it's constantly asking questions and answering questions for the students as they go. And so as I'm working with the students and as I'm cycling around the room and trying to gauge the students' understandings, I really begin to ask those questions. What are you learning? How do you know that you're learning it? What does this tell you about the experiment that we're doing? What does this tell you about your learning? How does this relate to the other things? And what I'm often finding is that the students are able to give me not only quick responses to those questions, but they're also able to give me very accurate and well thought out, articulate answers to those questions. So that demonstrates to me that they are really invested in the inquiry model, even though they may not be knowing that they're working through an inquiry type of a lesson or an inquiry type of an experiment. But again, the idea that the students were able to think about what they knew previously and answer that question to modify their experiment on the fly and change it for the future really demonstrated to me that they were thinking about what they were doing and thinking about the data that they were collecting and coming up with those conclusions along the way to get them to their final end result. I do a lot of coaching when I'm doing an inquiry type of an investigation or an inquiry type of an experiment. And the nice thing about that is that because I've got many different groups, I have to differentiate between groups myself. So the type of coaching might be different. And I always tell my students, in an inquiry type of a lesson or an inquiry type of an experiment, I will never purposely steer them off course. My goal is to steer them back on course by giving them questions to think about, and so that they can modify what they're doing and really think about what they're doing to try to arrive at some end result that's going to be usable for them. I'm very strategic in the groups that I set up for my students. And so what I do is I heterogeneously group the students so that they're students of all abilities in all groups.
So what we do is we take this equation and we'll substitute this equation within it.
Okay.
So it makes it a little bit easier for us, so we don't have to go through two equations, just one. And basically from there, all we really have to do is set up the reaction within the test tube and measure the temperature of the water in the system surrounding the test tube, and we have to see the initial temperature and when it reaches thermal equilibrium. Alright. So we're not doing time intervals, it's just two measurements, initial and final.
Alright.
and then from that, we'll be able to figure everything out.
Okay.
You really need to be tenacious in order to implement the strategy of inquiry in the classroom. It is so cognitively complex for students. It really takes a lot of building up and coaching to get the students to a level where they're really doing true inquiry on their own. When students come into my classroom, there is a very wide range of ability to do inquiry and desire to do inquiry, because it really is something that the students have to really work their way through. It is hard. It really is rigorous, and the students have to work really hard. As you are working through an inquiry lesson or an inquiry unit, it may not work the way that it was intended, but not to quit on it and to try again, because the students really will buy into that model. The other thing to keep in mind is, with that tenacity, it's also so important for the teacher to be supportive of the students. Because it is so cognitively complex and so rigorous for the students, it's possible that students will get discouraged. And it does happen that students get discouraged, especially if there are areas where they really are not able to answer those questions that they're trying to answer, or something comes up on the fly that they didn't anticipate. And so to really just be supportive and encouraging of the students, and that sort of goes back along the lines of the coaching concept. In order to have good inquiry lessons, you have to be very well planned. You have to have a vision for a unit. You have to have a vision for what it is that you want students to achieve by the end of the unit. And that really takes into account planning not only for a lesson, but planning for what they have learned before and where they're going to be learning afterwards. The biggest thing about it, too, is that inquiry is not something you can just sort of pull out of your hat or come up with 24 hours in advance. You really need to have several days in advance to really be thinking about what it is that students should be doing and how you want them to learn in order to be successful with it.
I think we should definitely do at least two.
At least two?
Because our first one will probably like be a little bit messed up,
Yeah.
since it's like we're trying to figure out how exactly we're going to do it.
Right. Okay.
So then we'll see how much time we have after we're done with the second one. I mean, after we're done with the first one, we'll try it again.
So only need one
Right. Only 1 gram of the
gram.
sodium
Yeah.
sulfate, and then 0.6 grams.
One thing that I've done in the past, when I've had students who've been really resistant to the inquiry model, really just working with them, building a strong relationship with them to have them understand that they can work their way through it. I find so many times it's the student who does not want to do poorly, who doesn't want to get the wrong answer. And if a real emphasis is put into the idea that it's not about the answer, it's about the process, then that makes it work a lot better for the students as well. I personally try to embed one inquiry experiment in each unit that I do. And the nice thing about it is that by the third or fourth unit, the students have gone through the process 3 or 4 times, and they buy into what I'm trying to do with them, and they're a lot more susceptible to going through the process the way that I want them to go through it, so that they're able to really come up with a good return on their investment of time. When inquiry is done, I really think that it helps a student's confidence in asking and answering questions. It really helps them to move their brain forward and to get them to think about things in a way that they haven't thought about them before. When inquiry is done best, really new questions come up along the process. And I think that can be applied to everywhere, whether it's in a science classroom or whether it's in the real world. The idea that if something comes up that you are not anticipating, and you're able to reason out and come up with answers to that, or some kind of a conclusion or a new question that might help to drive a direction that you're trying to go as a person, then I really think there is a strong benefit to it. You don't get that without practicing inquiry, without practicing asking and answering questions. You can't get that by answering questions on worksheets and end of chapter questions in textbooks and those sorts of things. Those are things that you can only learn by going through processes and trying them and failing at them. And when you fail at them, asking a new question so that you can continue to move forward.